Biodegradable Glove Group, and for our project, we are creating a non-sterile procedural biodegradable glove for our client, Dr. Alan Aquino. The goal of this project is to create an eco-friendly, single-use glove while still retaining the same functions and properties of the current glove.
Some specifications for a project is that it must be biodegradable and non-toxic, and it must be able to decompose wherever it ends up, as it might not be recycled properly. Finally, it must act like the current gloves with similar permeability, rip resistance, and tensile strength.
First, we did research individually and then came back to brainstorm as a team.
What we found was polylactic acid, which is a biodegradable plastic polymer that has recently gained attention as an alternative form of food packaging. It is biodegradable and is decently flexible as a material, similar to the nitrile rubber glove. In this clip, we have all of the materials that we used for the polylactic acid and cornstarch material. We have unmodified cornstarch, our plasticizer, which is called octaphenyl ethoxylate, our solvent, Triton X, the polylactic acid powder, ethanol, and water. First, we measured out an amount of our plasticizer and mixed it with the polylactic acid powder in a predetermined ratio to create our elastacil. Then, we added Triton X and dissolved the mixture with ethanol. Then, we stirred it over the hot plate, and once most of the ethanol had evaporated, we began adding measured amounts of water and unmodified cornstarch to thicken our material. After that, we waited.
Our end material did allow some stretch and was able to be molded, however, our sample sizes were too small to test.
Our second solution was a cornstarch and silicone glue material, which we chose because those materials are both biodegradable and together create favorable qualities like a strong rip resistance, high tensile strength, and low friction.
Now shown are the materials we used for the cornstarch elastomer. We have canola oil as a nonpolar solvent, the unmodified cornstarch, and our elastic resin replacement of blue silicone glue. The fabrication method began with measuring the proper ratios of all ingredients. We mixed the cornstarch and oil and then used the sonic desiccator to disperse the cornstarch evenly. After this, the addition of the elastomer allowed for the material to begin polymerization. The blue silicone glue was added as a stable binding agent. Finally, the mixture was degassed to remove air bubbles which would have formed holes in the material when poured into a mold.
We had some variation in our results. Some samples were solid and others more closely resembled liquids and were unable to be tested.
Both the materials were decent alternatives, but due to various circumstances, we were unable to test them to compare them to the nitrile glove. Overall, we learned how to work effectively as a team, as well as a lot about biomaterials and their impact.